Black holes, the universe's most mysterious phenomenon. Black holes, immense, powerful, and unfathomably complex, are some of the strangest objects in the universe. They defy our understanding of space and time, bending reality itself. But what exactly are they? And what would happen if you were to fall into one? To comprehend black holes, we first need to explore the very fabric of our universe, space and time. The stage of the universe, space and time. Imagine the universe as a vast, ever-changing stage. Space and time are not rigid or fixed, but rather flexible and interconnected, forming what physicists call space-time. Everything that exists, stars, planets, and even you, affects this stage. In simple terms, mass bends space, and bent space dictates how matter moves. Picture a trampoline. When you place a heavy object, like a bowling ball, in the center, the fabric bends around it. If you then roll a marble near the bowling ball, it will spiral inward, following the curve. This is gravity in action, a result of the curvature of space-time. Now imagine an object so massive, so dense, that it doesn't just bend the trampoline, it punctures it, creating a bottomless pit. That, in essence, is what a black hole is. A region where gravity is so strong that nothing, not even light, can escape. Birth of a black hole. Most black holes form in the final moments of a massive star's life. As the star exhausts its nuclear fuel, it can no longer support itself against gravity. Its core collapses at nearly a quarter of the speed of light, packing an enormous amount of mass into an incredibly tiny space. The result is an object so dense that it essentially breaks the fabric of the universe. A black hole with 10 times the mass of our sun would be only about 60 kilometers across, an astronomical giant compressed into a city-sized sphere. Yet, despite their immense influence on the cosmos, black holes appear invisible to the human eye. Seeing the unseeable, how we observe black holes. If you were to look directly at a black hole, you would see nothing. Their defining feature is an invisible boundary known as the event horizon, a point of no return. Once anything crosses this threshold, it is lost to the universe forever. So how do we study something we cannot see? Fortunately, black holes have a dramatic effect on their surroundings. They often have disks of superheated matter swirling around them, spiraling in at near-light speeds. The friction and collisions between particles in these accretion disks heat them to temperatures of billions of degrees, making them glow brilliantly. Ironically, while the black hole itself is invisible, the space around it is one of the brightest places in the universe. The journey into a black hole. What would happen if you ventured too close to one of these cosmic behemoths? The experience would be unlike anything imaginable. The distorted view. As you approach the event horizon, you would encounter an optical illusion like no other. Black holes don't just bend space, they bend light. Photons, particles of light, can orbit a black hole just as planets orbit a star. If you hovered near the photon sphere, the light from your own back would loop around and hit your eyes, meaning you'd see the back of your own head. Every direction would appear to contain a warped and twisted version of the universe behind you. Time, dilation, a one-way trip to the future. Gravity doesn't just warp space, it alters time as well. Near a black hole, time slows dramatically. To an outside observer, you would appear to move in slow motion as you inched toward the event horizon. From your perspective, however, time in the outside universe would accelerate. If you somehow managed to escape and return to Earth, you might find that millions or even billions of years had passed. Your home long unrecognizable. Spaghettification, a grim fate. If falling into a black hole sounds exhilarating, think again. The extreme gravitational forces create a phenomenon known as spaghettification, because gravity is stronger at your feet than at your head. Your body would be stretched into a long, thin strand of atoms. Eventually, you would be reduced to a stream of hot plasma, swallowed by the black hole in one final gulp. However, this gruesome fate only applies to smaller black holes. If you fell into a supermassive black hole, like the ones at the centers of galaxies, you might cross the event horizon without immediate harm. But make no mistake, your journey toward the singularity would still be inevitable. Inside the event horizon, a place beyond understanding, once inside a black hole, all known laws of physics cease to function. The singularity at the center is a point of infinite density, where all matter and energy are crushed into oblivion. Anything that enters loses all trace of its past. Black holes retain only three characteristics: mass, spin, and charge. Everything else is erased from existence. Scientists struggle to describe what happens inside black holes because our current understanding of physics breaks down. The equations of general relativity predict infinities, meaning our theories are incomplete. Some believe that singularities don't exist at all, and that new physics, perhaps even quantum gravity, will one day reveal the true nature of black holes. The ultimate fate of black holes. Will black holes last forever? Surprisingly, no. The famed physicist Stephen Hawking proposed that black holes slowly evaporate through a process known as Hawking radiation. In quantum mechanics, space is never truly empty. Instead, tiny particle-antiparticle pairs constantly pop in and out of existence. Near a black hole, one of these particles might fall in while the other escapes, carrying away a tiny amount of energy. Over unimaginable timescales, black holes lose mass through this process. However, for most black holes, this process is agonizingly slow. A black hole with the mass of the Sun would take 10 to the 67th years to evaporate, a number so vast that our human minds can barely comprehend it. The most massive black holes in the universe could persist for 10 to the power of 100 years or longer. To put that into perspective, if every particle in the universe were a grain of sand in an hourglass, and only one grain fell every 10 billion years, the entire hourglass would still not be empty before these black holes vanish. The unanswered questions. Despite all that we have learned, black holes remain a frontier of mystery. What truly lies beyond the event horizon? Could black holes connect to other regions of space through wormholes? Is it possible they lead to entirely new universes? And will we ever fully understand them? Perhaps not. But that's what makes them so fascinating. The mysteries they pose drive us to push the boundaries of human knowledge, to explore, to question, and to wonder. One day science may provide us with the answers. Until then, black holes remain some of the most tantalizing enigmas of the cosmos, waiting in the darkness, holding their secrets beyond the veil of time and space.